Recording is running, so we can switch to English again. And in this third lesson of today's morning, we are going to build an ASP.NET Core application. We are going to build the event management that we started in Swagger, but this time we're going to implement it in ASP.NET Core, and I'm going to show you a lot of things which we haven't covered before with ASP.NET Core. So let's create a new project here. We are going to implement an ASP.NET Core web application as usual. Next. And let's call it Event Management API. You can call it whatever you want. I will call it Event Management API. Good. Please select .NET Core Web API, as usual, ASP.NET 5. It doesn't matter whether you use configure for HTTPS. The only thing that I would definitely ask you to do is add Open API support. Create. Let's put that here. And with that, we have a new API. That's nothing special. You have done that before. You have done that in the last exam very well. So yeah, nothing special here. As usual, we are going to switch away from Internet Information Server to our Event Management API to run it inside a console app. So I think that's the better option. It's easier to maintain if you ask me. And the other thing that we are going to do, we are going to delete two files. We are going to delete that one and we are going to delete that one because that is auto-generated sample code. And I would like to show you step by step how we add a new controller and how we add the controller operations and things like that. So please delete these two things. First, weatherforecast.cs. Let's get rid of it. And here, weather forecast controller, delete it. And it's gone. Please try to build your application. It should build without any warnings, without any errors. It should just work. I will give you a second to catch up. Good. I assume you have now created or deleted the things. Everything builds correctly. If you have any problems, please interrupt me, tell me that you need more time or ask your questions. We are going to build an event management API. And now for the first time, we are going to do something which you always should do when you create some kind of web API. You should always separate your business logic or your data access logic from your API controllers. I know up until now, we accessed our entity framework classes directly from within our ASP.NET Core controller methods. We should not do that in practice. We did that because we were just beginners, we were just practicing, and it's fine for beginners, but now you are no longer just beginners. You are more advanced users of ASP.NET Core, and therefore we are going to split, we are going to separate our helper methods for business logic and data access into separate classes, okay? In many cases, people call these classes services. Services because they are services within your application. So what I'm going to do here is I'm going to add a folder and call it services. But that is just the name that I have chosen. If you don't like services and you would like to call it data access or business logic, or in a larger application, maybe you don't have a single folder, but you have certain topics and you create multiple folders, it doesn't matter. It's just a place where you put your business logic, your data access, whatever. Just structure your project properly. In these services, we are going to add a very simple plain class. Typically, we would now add some entity framework and modal classes, but we want to keep everything simple here. So therefore, we are going to use just an in-memory representation of our event list. So we are going to use just a list of T and skip the database for now. The reason why I do that is because I want to keep the noise content ratio good. We want to focus on ASP.NET Core now, but don't worry, in the upcoming weeks we are going to bring together Entity Framework and ASP.NET Core again. But for now, it's just in-memory lists. Let's call it events repository. Or let's call it event repository. No, event. Oh, we can discuss that. I will call it events repository. I like that name. Repository is just a name for a pattern that says here we can store events. Repository is a kind of name for a generic store of data. Okay? You can call it whatever you want. If you want to call it events store, that's fine too. But very frequently you hear the class name repository for something that we do here. Now in this events repository, we need to represent an event. And in practice, I would now do the following. I would go to our, where do I have it? To our document here, for instance. Let me see if I still have it here. Yeah. Exactly. I would take a look at this schema from my OpenAPI specification and then model my classes inside of my C# according to this schema. So an event consists of an ID, of a date, a location, and let's add a description also. So the specification is now the basis for our writing the code. Let's go back to the code here and model. The easiest thing would be a record. Let's model a record. Let's call it event. And this event should have an integer ID because here we have an integer ID. See it? Then we have a date time date because we have a date. I think you get the idea now. A string location and a string description. Okay? Do you absolutely have to use a record here? No, you don't. You can also use a plain class. A record is just a very good and elegant way of defining a data structure that has a constructor with which we can create it. So a record is really a nice thing for a so-called data transfer object. It's just an object which you use for storing some data and transferring it between services and things like that. If you don't like records, it's perfectly fine. You can use a regular class and create an event and create all the different properties and so on and so on. It's fine. It's just up to you. Records are a pretty new feature in C#, and for web APIs, I really like to use them. Behind the scenes, they are just a special form of class. Okay. Good. Now in this events repository, we should not and do not care about the HTTP protocol. We do not care about how the events are represented on the network wire. We just implement the necessary business logic or data access logic for storing and retrieving events. This should be completely independent of any kind of web API. It doesn't matter if that's a web API project or a full client API or a mobile app. This repository implementation should always be the same. So forget about ASP.NET Core for now. We will just implement the necessary operations for maintaining events. What could that be? Public, event, add, event, new event. That could be our first method. We are adding an event and we are returning the event that we just added. Why do we return the event? Well, maybe the event, the new event here, was changed in the course of adding it to the repository. Think back. Entity Framework. Can you remember primary keys? The primary key is 0 before you call save changes, and after you called save changes, you magically get the primary key from the databases inserted in the data record. If something happens like that, We just return the same event with all the changes that happened during adding the event to the data store, okay? That's just a convention. Many people do that and it's a good idea. Okay, let's implement the event. We have to store the events somewhere. So let's create a private list of event. This will be my events. Okay, and let's just do a get operation here, something like this. And we can also create this thing immediately here. This will just initialize and declare a store for our events. In real life, let's comment it here. In real life, use EF core. So in real life, we don't have a list here, but we will have a data context and use the data context to access the underlying database. But for our simple example, we just use a list here. Now let's add the new event to the events. Events, add new event. And return new event. In our case, everything is unchanged. We just return the same object, but I already told you if we would use Entity Framework, then we would probably get a changed event back. Okay? Very simple operation. Next one, let's add a method, public IEnumerable of event get all. Return events to, let's add a array, something like this. We can even just return events here. Okay? If you have a method like that, you can simplify it to a great extent by using the expression syntax. You can just write it like that. I think I've shown you that before. It's exactly the same. It's just a shorter form. You don't need the curly braces. You don't need the return. Just a recap. Get all. Let's implement a public event get by ID, which takes an integer ID and should return the ID of should return the event with the specified ID. So what we do is we say events dot first or default with event ID equals ID. First or default is important. The or default means that the method returns null if there is no event with the given ID. Okay, that means the or default. If we would specify first and there is no ID, we get an exception. I don't want to have that. I just want to add null. Another tip here, it is a kind of naming convention. If you no, forget it. It's not that important. I'm losing track here. It's fine like that. It's perfectly fine like that. Okay. So that is the get by ID method. So we have an add, we have a get all, we have a get by ID, and the last one I would like to say public void delete int ID. We want to delete something from here. Okay? We can do the following. We can say, var event equals to get by ID ID. Oh, sorry. Event is a event to delete. Event is a reserved word in C#. So we are getting the event. If event to delete equals null, then we have a problem. See it? The problem is this ID doesn't exist. So let's throw an exception. Argument exception. And in the argument exception here, we can specify some, come on, I want to show IntelliSense here, argument, of course, new argument exception. We can specify a message and the parameter name. So no event exists with the given ID. And the second parameter is the name of the parameter which was wrong, which contained invalid data. Name of ID. Otherwise, we just say events.remove event to delete. Get it? So now we have add, we have get all, we have get by ID, and we have delete. I will give you a second to enter this code. Let's make it a little bit smaller so it fits on the screen. I'll take a sip from my coffee to give you time to catch up. Don't get me wrong, this is not a professional implementation of an in-memory repository. So this is not production code. In real life, you would have to write much more code because, of course, the HTTP requests can run in parallel. They can run at the same time. You have to think about data races and semaphores, locking and protecting the list of events and things like that. But that's not our topic here. So our topic here is not implementing a perfect in-memory repository. In real life, we would use the database, and the database would care for that, okay? Now, today, we want to focus on ASP.NET Core. So it's fine to build a repository like that. It's very, very simple. And for your homework, an implementation similar to that is okay, because our core focus today is ASP.NET Core. Not, and I repeat myself, not the implementation of a perfect in-memory repository. Does anybody need more time writing that code? Is it fine? Good. That code is now completely independent of ASP.NET Core, and that's fine. That is exactly what we want to have. Now let's switch gears and go to ASP.NET Core. Let's add a controller. Right-click on the controller, add controller, API, empty controller. Go for it. Let's call it events controller. Why did I call it events controller? Well, because here we specified that the path should be called events. And we know, if we take a look, that here the controller name is injected into the path. And therefore, in this case, if I want to fulfill the specification, I call it events controller. Because, again, here, events. You can choose a different name and then change just the name up here, but at the end of the day, you should fulfill the specification. Good. Now we have a problem, because this events controller needs to have access to this events repository down here, to this one. How does the events controller get the events repository? The most simple thing would be the following. We can create a private member, private events repository, make it read-only, and generate a constructor where we just say repository equals new events repository. We could do that, but it's not good. It's not considered good style. This shouldn't be the way that you develop your professional APIs. Why is that the case? The reason is that our events controller here, which implements the web API, and the underlying business logic class or data access class is now tightly coupled. You see it here? They are bonded. These two things, they can't be separated. The events controller has hard-coded that it needs and wants to use the events repository. At one point in time, you could say, you know what, let's add a second service, let's call it database events repository with entity framework core in the backend. But then you have to change the events controller in order to make it using a different implementation of the repository. If you want to write a unit test where you don't have this repository, but you want to use a so-called mock object. I'm pretty sure you've heard that term before. Mock object means you are just simulating the existence of a repository. Because during testing, you don't have a physical database, so you want to simulate the existence of a database. That is called a mock object. It's not possible here because the events controller is hard-coded to use the events repository. So this kind of having dependencies between classes hard-coded inside an ASP.NET controller is not considered good programming style. We do something different. And this is an important pattern that you definitely need to remember. We will practice it today. We will practice it over and over in the next few weeks. And I want you to really understand it. How does that pattern work? You go to your events repository and you create an interface for your events repository. So what I do is I generate here a new class which I call iEvents repository. iEvents repository, like interface. And then I'm going to do the following. Let's put that side by side. I'm changing that to an interface, see that one? And then I add all the methods that my repository is capable of doing to my interface. So I add the add method, first one. I add the getAll method, not the implementation, just the signature of the method. I add the getById method. And I add the delete method. See it here? That doesn't have very much value yet, but I can now take the iEvent repository and make my events repository implement this interface. You see? Now we say we have a contract. This is called a contract, okay? A German Vertrag. A contract between our Web API controller and the repository. The events repository promises to fulfill this contract. The events repository says, all these methods, dear Web API controller, you can rely on the fact that I implement those methods. The events controller, the API now, will no longer directly access, here I can show it to you, the events repository. We will switch that to an iEvents repository. So we essentially say, I as the controller can work with anybody who fulfills that contract. Whoever implements this interface, I am fine with. If this is an in-memory repository, it's okay. If this is an entity framework backed repository, I am fine with that. If this is a mock object, just simulating the existing of a database during unit testing, I am fine with that too. Now, this is of course wrong because I want to get rid of the events repository. Can I just create an iEvents repository? No, that's not possible because you cannot create an interface. That's not possible because we don't know with whom we want to work. With the database repository or with the in-memory repository. That is no longer possible. The question is, where can we get the concrete repository from? Who is the authority saying, if somebody wants to have an iEvents repository, This is the implementation that we are going to use. The answer to that is dependency injection. You've heard about dependency injection in other courses. Remember dependency injection in Angular, for instance. And I think we have also talked about dependency injection, but today we are going to dive much deeper in it and take a view on dependency injection from the standpoint of ASP.NET Core. We go into the startup method here, startup. Let's put it side by side here. And in the startup method, what we can do is here, we can register the dependency injection configuration. You have heard about startup before. Can you remember? What did we do in startup so far? Register the data context for entity framework. But now we are going to configure services here and configure our events controller. So what we are going to do is we will say services dot add singleton. Singleton means there is only one repository, so that all the events are stored in a single instance of a class. We'll talk about that maybe in the next lesson. For today, add single is fine. And then we say, if somebody asks for an iEvents repository, return an events repository. So we are linking the contract iEvents repository with a concrete implementation. The controller, on the other hand, can now say, hey, ASP.NET, give me an iEvents repository. So it can just it can just ask ASP.NET to give him an implementation that fulfills the contract. And now we have just to remember this guy. This.repository equals repository. And this is now linked by ASP.NET. By adding this line, we will, whenever we ask for an iRepository, zoop, here is the iRepository. Whenever we ask for an iRepository, ASP.NET Core will give us an events repository, the in-memory implementation of our events repository. And when we want to switch that to an entity framework repository, we need to make a change on a single line of code, exactly here. We can change it here from in-memory events repository to entity framework events repository, and boom, everybody who asks for an events repository will create and get a different class. Okay, that was a lot of information. Do you understand what I mean? Do you have any questions regarding that? Fine? Good. Having the repository implementing the ASP.NET stuff will really not be difficult. The first thing, let's add a repository, a controller operation which returns all the events. Let's do that. HTTP get, because we are reading events. Public. Up until now, we would have always written here IEnumerable of event. That is the pattern that we have used so far. But now we are switching away from that pattern. We are now returning an iAction result. There are other options too, but currently we are going for iAction result. Get all. And the implementation is return. What kind of status code do we want to return in case of get all events? 200, okay, correct? So we write okay. That will return, see it here, a 200 status code. And inside of the okay, we specify the result that we want to return. In our case, repository.getAll. That's it. So the business logic for accessing the database, in our case it's just an in-memory list, is separated from our events controller. The events controller knows which status to return, and that's it. That is the most simple and robust, no, it's not perfectly robust, but it is a simple and good implementation for this API method. We can make that simpler by using the expression syntax. It's up to you. If you prefer the curly braces, write the curly braces. If you like the thing that I've written here, then it's fine. Okay? I give you a second to catch up. Now, ASP.NET Core has a little bit of a problem because it just sees iAction result. By looking at this method here, this one, it doesn't know what it really returns. It doesn't know that the result will be a collection of events, because from the method signature, it just sees, okay, this returns an action result. For that, it is possible to add an additional attribute here on top. We can say produces response type. Here we can say, in this case, we are returning an status codes dot 200, okay, and we return the type of IEnumerable of event. With that, we can tell ASP.NET Core that the implementation will return a status code 200, and if there is a status code 200, it will return a collection of events. This one is important because if we take a look at the specification here, we have 200 and we are returning a collection of events. Get the idea? I hope you do. Okay, that was for warming up. Let's do the next one. Let's do adding an event. What is the correct HTTP method for adding data? It's post. HTTP post. Public iAction result. Add. And then we get an event, new event. Where do we get it from? From body. We are getting the event data in JSON format from the HTTP body. Okay, got it? Nice. How can we add this event to the repository? We just say repository.add new event. We are okay. What do we return? Okay, new event. Is that one correct? Did I use the correct status code? No, which one should I use? Exactly, and luckily there is a ready-made method for that, created. But this method, created, has a problem because it needs, you see that one? It demands a URI where the created element can later be retrieved again. So we have to specify here some kind of URI where the created event can be found later on. Oh, I forgot the return statement. I'm sorry, return. See that one? So this is something, this is a to-do. Let's open it up. Let's keep it open for later on. We will have to change something here, and I will show you what we will add here later on. Okay? Looks good? What if the user specified something invalid? For instance, if the user specified a negative event ID, if new event dot ID is lower than 1 or 0 or whatever you want, it's just wrong. What do we do then? Return bad request, and we can here add some additional data. Okay? We can, at the very simple way, and we will keep that simple for the moment. In the next 2 weeks, we'll talk about error handling a little bit more, but now we say invalid ID. So with that, we return a bad request, status code 400, in case of a wrong ID, and we will return a created 201 in case of a created option. Now we have to generate the produces response type. Okay? Produces response type 201 created. And what will be the response in case of a 201, a single event? And we will also generate status 400, and the response will just be a string. In our case, here will just be a string. We can also leave out the type if we don't want to specify the type. We just say this method might return a 400 code, but it also might return a 201. Understand it? I hope so. Next one. Delete. HTTP delete. Public action result. Delete. And here we will get an ID, because we have specified that in the URL, the ID of the event should be part of the request path. So we say int event ID, event to delete ID. Let's put it that way. The problem is, where do we get this event ID from? And the answer is, we will add a route statement here, another route statement, which is relative to the route up here. And we will here just say, let's get a parameter, and this parameter is called event to delete ID. So this route will make sure that this method can be called with http //api .myserver.com/api/events/4711. That will be the ID, and that will be the ID here, and it will be an integer. Good. Nice. So let's delete the ID. Var try, because remember, in the event repository, the delete method throws an exception if the ID did lead to a non-existent event. So repository.delete event to ID, to delete ID. Let's catch the argument exception. Okay, let's get back to our example. We catch the argument exception. If we have an argument exception, we know that the event does not exist. So we return what? Not found. See that one? We do not use the exception here, so we can get rid of it. We just say catch an argument exception. If there is no exception, we return what? Okay. No content. Because we want to return let's see, 204. Exactly. So that is an example for a delete method. Now we have get all, we have add, we have delete. The last thing that is missing now is the get by ID. I will add it here after the get all method. Oh, I forgot something. Sorry. Quickly go back to the delete method. I did not add the produces response type here, of course. Of course, we have to specify that. The delete method in our case can produce, what can it produce? It can produce a not found, or it can produce no content. Here it is, no content. So don't forget that one. In the next exam, already a homework, I would like to see proper produce response type attributes on top of every API. It's just a matter of good documentation. Now, we will go back to our get by ID. So we make another get, HTTP get, it's correct. Public I action result, we know that already, get by ID. And the good thing is that we can now copy a little bit from our delete method, because this delete method here already got an ID. Here we just say ID because it's not to delete. And we already know that we have to use the route statement here and just change the name of the parameter. Let's take a look at the implementation. Get by ID will either return the event or return null if the event does not exist. This is how we have implemented. So let's say var event equals to repository dot get repository event existing event get by ID. If existing event equals null, we will return not found. Otherwise, we return OK with the existing event. Get the idea? Not difficult, is it? Let's add the produce response type. We already created a not found, so I will just copy it here, put it here, and maybe I will copy that one up here. Status code 200, but we return an event. Now that looks good. Now we have get all, get by ID, add, delete. This is what I wanted to show you how to implement. I will give you a second to catch up. If you have any questions, just interrupt me, okay? If you're done, run it. And do you see what we get? We get a Swagger file. This is the Swagger file that ASP.NET Core automatically generates from your C# code and your proper attributes. So it interprets all the stuff that you have implemented and it will give you the Swagger file auto-generated. You did not have to enter all these things in the Swagger editor. So ASP.NET Core with its Swagger integration is capable of generating this documentation out of the box. We can even take a look at the technical Swagger file. This is the technical Swagger file in JSON format, and it looks pretty much the same as what we have entered. You see that here as what we have entered in our Swagger editor. So this is super, super useful. If we take a look at get events, we even get, see that one? Nice documentation of our C# classes. Here we see the response codes, for instance. We see the post event, the get event by ID. You see that one with the required and all this stuff. So this is really, really super useful. And you might ask yourself, why did Mr. Stropek show us how to write that by hand now that we can just generate it from our C# code? Well, you are right to a certain extent. This is generated from your C# code, but in real life, you cannot just invent your API. You have to think about it first. So the typical workflow in a real life API project is you write a documentation, a specification like that. This will be your specification. This forces you to plan. Can you remember what I told you at the end of the last lesson? You need to plan a little bit. This will be your concept. You walk out of the door and you make a at least rough plan how to get to Vienna. This was the picture that I used. Then you really implement the code. And the nice thing is that if it turns out that during implementation you find out that your plan wasn't perfect, you have to make slight adjustments to your plan. And the beautiful thing here is that you do not have to enter the slight adjustments manually here, but once you have implemented your API, you can forget about this thing. This will be in the past. This was your plan, and this is reality. This is what you really implemented. And that's the whole idea. Use Swagger to specify, then implement, and from your implementation, generate the documentation, which is really 100% in sync with your implementation. You do not have to manually maintain your plan. You can just generate it. That's the workflow. Another nice thing is that we can, if we want, directly try out the API here. You see, try it out, click on try it out, click on execute, and the result will be, as you can see here, an empty array. And this really executes your API. Let's try to add an event. See that one? Try it out. Here, let's specify ID, date, I don't care about, can be something. It will be somewhere, and the description will be a great party. If I hit execute, we will get a response code 201, exactly as we expected. And if I scroll up again, go to the get events and execute it again, we now get our great party. So once we have our Swagger documentation, it's really very useful to also try out the API. Of course, it's not absolutely necessary. You can also here type it in the browser, 5001 get events and get HTTPS. I forgot API. I'm sorry. API. Come on. I misspelled it. Good. Now we are done. Sorry for my messing up here. Okay? Now that looks pretty good. And that is exactly what I wanted to show you today. And we have now finished a third lesson. It's 11 o'clock, and that was exactly my plan, to use 3 hours to recap HTTP, to talk about Swagger, and then to implement an API in very much more details compared to what we did before. So what do you have to remember in ASP.NET Core from this lesson? You have to remember that you should never directly add business logic or data access logic interacting with your database context directly in the implementation of the ASP.NET Core controller. You shouldn't do that. What you should do is you should extract your business logic, your data access logic into separate classes where you offer some helper methods, some services to the rest of your application. First one. Next one, use an interface to build a contract between your ASP.NET Core implementation and your business logic or data access logic. Then, third thing, go to the startup class and register your classes with the services. I told you that there are multiple options here. It's not just add singleton. There is more to talk about, but hey, we only have 3 hours today. It's fine for today and for this homework that you have to do. Just to remember add singleton, that's fine. Here we are connecting the interface with the implementation. In ASP.NET Core, we are then using constructor injection to get an implementation based on the interface. But there is no tight connection between the implementation events repository and the controller events controller. The interface is in between. This is the abstract contract between the controller and the implementation. In the controller, you use the HTTP methods. We talked about them at the beginning of this lesson. Get, post, delete. We could also add a put or a patch, but that will be part of your homework. We add, if necessary, some routes. We add some attributes to document which kind of response codes we are going to create. We are adding some logic where we mainly call the underlying business logic or data access class and just translate the responses into proper HTTP responses like not found, okay, created, and so on. And here we have the no content. Now we still have this to do down here, and I told you that we need to change something here in order to reference another action. It has to do something with the location header, and you will see that in the result in a second. So how do we do that correctly? First, we need to change the definition of our getById a little bit. We have to move this parameter here into our HTTP get. So I remove that one, and now the route is directly in the HTTP get. And then what I can do, I can give this route a technical name. So I can say this name is name of getById. So the technical name of our route should be identical to the name of the method in C#. With that, we now have a technical name with which we can reference this route from this created here. So what I can now do, I can say created at action and give it the name of the route, the action it's also called, so name of getById, and tell it that the ID parameter up here in this case is the new ID, new event .id. That will now link the result of the add method to the getById and the ID parameter here. And what is the result of doing that? Let's try that. Application coming up. Here is our Swagger document. If I now create a new event, data doesn't matter, click on execute, and this is the result. This is what I was fighting for, the location header. I now automatically get the location header with which a user can retrieve the data she just added with this body. Okay? So let's go back. If we want to get rid of this to-do, move the route parameter into the HTTP get and use the created at action to link the result of one action to another action. Or to link the location header of the created response to another action which can be used to retrieve the data that we just created. Okay. Now, what is your task for the rest of this morning's lesson? Your task for the rest of this morning's lesson is to work on the homework, on the classroom that I gave you. So let's quickly take a look again at the exercise. Your classroom is that one. You have to implement a contact list, and for that you have to take a close look at the Swagger file. We already worked it through, so you already know what to do, but you have to take this Swagger file as a specification. It's fine to implement an in-memory implementation. So just as we did now, use a list, that's fine. You do not need to use Entity Framework. If you want, you can, but it is not necessary. Here I also told you to use nswag, but you can use swashbuckle too, you can make it exactly like we did in the lesson here. And I want to have at the end of the day an ASP.NET Core implementation which does exactly what this Swagger files demands. Okay? So you have to implement the get, post, and so on. If you want to make your life easy, you could just copy the code that we created in this lesson, make a few changes, and you are done. I would not recommend that. You can do that. It will be a fast track to a solution, but you will not learn a lot. My recommendation is that you open the code that we have written throughout this lesson on one hand, and then create a new solution and try to build everything on your own. And whenever you struggle because you don't remember how to solve a certain problem, then you take a look at the code that we wrote together during this lesson. That would be the most elegant way of learning and trying to remember all the things that we covered in this lesson. Can you earn an extra point? Yes, you can. If you fulfill all the requirements and you are done, check in the solution through GitHub Classroom and send me a GitHub issue, and then I will take a look at your solution, and if I think it is good, you will get an extra point, a thumbs up, then you know it. Everybody has to check in the best try. So it is mandatory. You have to check in something. I will take a look at random homeworks and make sure that you didn't just check in, I don't know, a git ignore file or something like this. I will not take a look at every homework if I don't get a GitHub issue, but you have a certain risk of me taking a look at it. So please try your best, okay? Nice. With this, we are done with the theory part. Do you have any questions now that we must discuss before you go into your exercise?